When you think of physics, you probably think of Newton's laws. The first law, inertia, which states that an object in motion tends to stay in motion unless acted upon. The second law, the net force applied to an object is equal to the mass of the object multiplied by the object's acceleration. And the third law, every action has an equal and opposite reaction, or in other words, what goes up must come down. These laws are essential to the ideas of classical mechanics. One thing that Isaac Newton could not explain was gravity and how it works. He knew it existed, but as Brian Greene says in The Hidden Reality, Parallel Universes and the Deep Laws of the Cosmos, in his Principia, published in 1687, Newton recognized the importance of this question, but recognized that his own law was disturbingly silent about the answer. This is where quantum mechanics comes in. What exactly is quantum mechanics? It's defined in the dictionary as the branch of mechanics that deals with the mathematical description of the motion and interaction of subatomic particles, incorporating the concepts of quantization of energy, wave-particle duality, the uncertainty principle, and the correspondence principle. Now, I'm not going to be fully explaining the definition because it's complex, extremely complex. But as Niels Bohr, one of the pioneers of quantum theory, once said, if you're not completely confused by quantum mechanics, you don't understand it. It can, however, be used for some very useful things. Something you might have noticed in that definition are a couple terms that we have learned about earlier this year in chemistry. So let's break that definition down. The branch of mechanics that deals with the mathematical description of the motion and interaction of subatomic particles. That essentially means that quantum mechanics, or quantum physics, is a branch of mechanics that deals with small particles like photons and electrons and how they move around. Now, the quantization of energy. This is actually something we learned about earlier this year, but what exactly is it? Well, simply put, it means that rather than coming in continuous waves, light and other subatomic particles come in packages of energy called quanta. One of the best ways I've found to explain quanta is like pixels on a computer or phone. If I go into Photoshop and draw a line, it looks smooth and straight, but if I zoom in, you can see that the line is actually made up of individual pixels. This ties in with another thing we learned about earlier this year, which is wave-particle duality. This concept shows that subatomic particles sometimes behave as waves and sometimes as particles. Henry Reich from the YouTube channel Minute Physics has a great explanation of this. If you send out an electron in a room, it would be emitted as a wave and could appear anywhere on a wall in the room. It can only appear in one location, however, because you only sent out one electron. Where the particle appears, however, is affected by a few factors. This animation done by the Physics Reimagined team in France is an excellent way to show this. Here you see that each regular particle acts as you would expect it would, traveling as a particle and landing on one location on the wall. The waves also travel as you would expect them to, traveling through the slits and canceling each other out in certain locations because of destructive interference, also known as phase cancellation. The red bars on the wall represent the areas where the phase cancellation didn't affect the wave and where the wave hits the wall. The quantum object here travels as a wave, but as you can see, it lands as one particle, just like wave-particle duality says it should. Because it travels as a wave, however, there is destructive interference, which causes the particles to only land in very specific locations on this wall. Now that you understand these basic concepts of quantum mechanics, we can get into the fun stuff. Over the next hour, I'll be teaching you step by step how to build a time machine. Okay, I'm kidding. There are, however, a few interesting things that quantum mechanics are used for right now. The electronics industry and modern computers and phones as a whole relies on the wave nature of electrons, which most people think of as particles. A few other things that you may encounter on a daily basis that use quantum mechanics include the GPS on your phone and lasers, which aren't as uncommon as you might think, being used in things like fiber optic cables, which transmit data, like in fiber internet, and in scanners for barcodes on groceries. These are things that you probably encounter every day. The current model of the atom, even, the quantum mechanical model, which is supposedly the model of the thing that makes up life and the universe as we know it, is based in quantum mechanics. Some people say that since it's a branch of theoretical physics, quantum mechanics has no practical application. So next time you use your smartphone, remember to thank all of the brilliant scientists who pioneered the field of quantum mechanics. It may seem impractical sometimes, but trust me, quantum mechanics isn't phony, or maybe it is. I want to thank you all very much for watching. I really enjoyed making this video, and I hope you benefited in some way from it. It wasn't necessarily made to be a full-on introduction to quantum mechanics. I just wanted to show how some of the things we've learned this year in chemistry can also be transferred to something that a lot of people think is terrifyingly complex, whereas it's not really that scary. It's pretty simple if you get down to the basics of it. And this is something that I am personally very interested in. I know it's not for everybody, but if you would like to learn more about this, I would recommend a few different resources. First of all, I would check out some of the videos on the YouTube channel Minute Physics, which I mentioned. If you're interested in some of the more fantastical theories of quantum mechanics, check out The Hidden Reality by Brian Greene, another thing I mentioned in the video. It's all about the multiverse and the possibility of multiple universes. Very interesting stuff. Another thing you can use to learn about quantum mechanics is an app called Quantum that you can actually download on your phone for free, and it offers step-by-step lessons and tests for you to learn more about quantum mechanics. Now, if you're interested in learning more about how gravity works, I would highly recommend checking out the video Which Way is Down on YouTube by Vsauce. It's an incredibly interesting video. It is about 26 minutes long, so it's quite a chunk of time, but if you're interested in learning more about how gravity works and things like that, I would highly recommend it. It is an excellent, excellent video. There are tons of other free resources online. These are just a few that I would recommend because they've helped me out and I have learned so much from them. Thank you all again very much for watching. I hope you enjoyed my video.